Hello and welcome to Balancing with Ben. I am Ben and I'm here to help you balance some chemical reactions. Let's get started with this doozy. You can see here we have ammonia plus oxygen plus nitrogen goes to nitrogen and water. We have two diatomics, which means two things which are essentially by themselves. They're not paired with anything else. What that means is we're going to leave those to the end, and we can easily here start off hydrogen, and then we're going to do oxygen and then nitrogen. To start off, we're just going to literally count how many we have. We got 3 here, 2, and 1 on the left, and on the right we have 2 nitrogens, 2 hydrogens, and we have 1 oxygen. Now, to start off with, we already have a more complicated one. If we did like the oxygen, you can see, oh, we just have to multiply the right by 2. But because we have a 2 and a 3, it doesn't quite work out that way. We need to find the lowest common factor, in this case 6, which is 2 times 3. And we're going to multiply both sides by that. And what that means is that we're going to multiply the left side here by 2 and the right side here by 3. And so that gives us on the left, that's going to give us 6 and 2 nitrogens. And on the right, that's going to give us 6 hydrogens and 3 oxygens. This once again. Now, to deal with a diatomic, the best way to generally think about it is whatever you're going to do is you're going to get the amount you need from the other side, and you're going to divide it by 2. I know you can't leave it that way, but you can keep it that way for just a moment, and you'll see why. So in this case, for the nitrogen, how many do we need from the left? We need 2. Well, that's an even number. That easily goes to 1. That's nice and simple. For the oxygen, we're going to need a 3. That's an odd number. And here's what we do in that case. If we have an odd number there, we're going to multiply the entire equation by 2. What that means, this is now 4, this is now 3, that is now 2, and this is now 6. If we now check how much that does, that's 4 times 3, that's 12, and that is 4 nitrogens. 3 times 2 here, that is 6 oxygens. On the right hand side, 2 times 2, that's 4 nitrogens. 6 times 2, that's 12 hydrogens. And 6 times 1, that is 6. And we are balanced. Okay, let's move on to our next one. Our next one here, we have iron, sulfur, and oxygen. Again, we have a diatomic, so we know eventually we're going to do that shtick. And we're going to leave that to the end. Also, we want to leave it to the end because you can see it appears in more than one place, making it a little bit more complicated. So that one's going to be last. I'm going to do iron and sulfur. Doesn't matter. You could have done it the other way. Might take an extra step or 2 here or there, but it's basically the same. So if we look here for iron, we have 1, we got 2, and then we currently have 2 oxygens. And for the right, the iron, we have 2 irons. Sulfur, we have 1, and then we could count the oxygens. Usually it's you're better off leaving it until you've done the rest of it, but what it would be essentially is 3 plus 2, which is 5. But if we move on to the next one here, let's go ahead and do the irons. We're going to need 2 there. Notice that affects the sulfur. Good thing we started with the iron. That affects the sulfur to give us 4. That means I'm also going to want to do the sulfur on the right, and so I'm going to do 4 here, and that also affects the oxygens on the right. What that brings me to is that for the right hand side, I will have the 3 oxygens, that hasn't changed, plus the 4 times 2, that is 8. 8 plus 3 is 11, which means this is 11 over 2. Once again, this is not a even number. It doesn't divide simply, so we have to multiply the entire thing by 2. That means this becomes 4, that stays as 11, this becomes 2, and that becomes 8. And if we want to verify that, we have 4 times 1, that's 4 here, 4 times 2, that's 8 there, 11 times 2, that's 22 for oxygen, 2 times 2, that's 4 for iron, 2 times 3, that is 2 times 3 for the oxygen. We'll get to those in a second. We have 8 times 1, so that's 8 here. Iron and sulfur, so far so good. 8 times 2 is that is 6, that's 16, that does in fact equal 22, and that is balanced. Moving on to our next one right here, we have a bunch of things: calcium, phosphorus, silicon, carbon. Carbon, you can see it's by itself, so we want to leave that to the dead last. Carbon also has direct influence only on oxygen, so we'll leave that next. Phosphorus, I can already see we're going to have to deal with that too, but that is again just like the diatomics, but I'm actually going to deal with phosphorus first because I know it will save me a step, but it's not required. If you don't, it's not going to make a difference. It just might take you one extra step. So if we start off with a phosphorus first, we actually are going to need to have, nope, not 4, because we forgot about that 2. So 2, because that 2 applies to both of them. Now that means 2, so our phosphorus here already, I'm going to start off, and I want to already start off with it there. I probably should have started with everything, but we're jumping right into it. Notice that this 2 applies to both of them. Make sure that it does. And so this calcium here is now at 2 times 3, that's 6, because I jumped forward a bit. The phosphorus we already did. The silicon here is still at 1. And the oxygens, again, oxygens in 2 places. I'm not going to deal with it right now. And the same thing goes to the carbon. I'm not going to deal with it right now. But on the right-hand side, we have 4 phosphorus. The calcium, we currently have 1. The silicon, we currently have 1. Oxygen, I'm not going to deal with right now. So to deal with the calcium, that's the biggest guy here, we're going to put a 6 here. And so what I'm actually going to do is that one in a different color to indicate that's the second one we're going to do. So that's going to be 6 here. And then the silicon, that will do the same thing. What that also means is we're going to need a 6 right here. And now that we've balanced the phosphorus, the calcium, and the silicon, we can look at the oxygen and the carbon. So how many actual oxygens do we have here on the left? Well, we have this 4 times this 2 times this 2 right there. So that's that. Plus 6 times 2. And so that is 12. That is 16. Grand total of 28. And on the right, we have 6 times 3 plus 1. But here's the thing. That 1 we can control. So whatever this is, we just have to subtract that. So 28 minus 18, that's 10. So we want this to be 10. Okay, so that will be 10 right there. This is now 10 here, which means that the total here is 28, and we have balanced that. Finally, our carbon is now 10 to 1. We just have to multiply that by 10, and we are done. Next one. Once again, starting with green. Here you'll notice we have polyatomics that don't break apart. That's the nitrates don't break apart, and the sulfates don't break apart. So that means I'm not going to touch them. So in this case, if we go in order, we're going to keep those polyatomics together. That should be a 4. And hydrogen. And so let's take a look. We got 1. We got 3 of these. Remember that 3 here. Let's go ahead and remove that so you can see what I'm talking about. So this 3 applies to the whole nitrate, with the inner 3 only applies to the oxygen. So we only care about the outer 3 for this particular case. And then we got 1 of these and 2 of those. And for the other side, we have 2 aluminums. We have 1 nitrate, and we have what's it called? We have 3 sulfates. There we go. That 3 applies to all of them. And then we have 1 hydrogen. Now, when it comes to double displacements like this, our best bet is to always go with the highest charge first. So that's plus 3, minus 1, minus 2, and plus 1. So the highest is in fact aluminum, then the sulfate, and then the nitrate. And that's the order I intend to do them in. And so for aluminum, I'm going to put a 2 right there. And so that changes this and that. And for the sulfates, I'm going to need 3 on the left, so I'm going to put a 3 right there. That changes this and that. now I can take a look here. And, well, the only thing I need to finish working on is, in fact, the nitrates. And that's 6 and 6. And I'm done. Then, last but not least, we have here a big old combustion reaction. And so for this one, I'm actually going to use a calculator just to make sure I don't get the numbers wrong, the big numbers here. But again, we know that the polyatomic, we are going to just divide whatever we get from the right hand side by 2, and we're going to leave that to the end. So it's going to be carbon, hydrogen, and then oxygen at the very end. So our carbon, of course, is 18, 38, and 2. And on the other side, it's 1, 2, and 1 plus 3, but 1 plus 2, but again, nobody really cares. We'll get to them when we get to them. So for the carbon, well, we have 18. We need 18. That makes it real easy. For the hydrogen, well, we have 2, so we actually need 38 divide by 2, which is 19. So that gets us here to 38. So those are now equal. And now let's see what that does for our oxygen. So that's 19 plus, well, times 1, but there's nothing there, plus 18 times that 2. And so 18 times 2 is, of course, 36, plus 19 is 55. Yeah, 55, and that goes right there. So that goes there. That's the amount of oxygens. Is that an even number? No, it's an odd number. It doesn't divide cleanly. What does that mean? Just like we've done this 60 times by now, we're going to multiply by 2. So that means this is 2. This now becomes 55. This is 19 times 2, which is 38. And this is 18 times 2, which is 36. And we are done. Oh, don't forget to like, comment, and subscribe. No, I'm just kidding. Have a great day. Put questions in the comments below. Remember, this is on the Jamboard, so it will be in a link in the comment down below.